All right, time for some more coding. We're going to continue with our bugs/issues. I've got a couple that I want to have a go at. But before we get to that, there were a couple of things that I realized after the last session that I had missed. One thing is we've made it now so that all the statements at the top level of a file, I think a good example is the OS Linux file. So all of these statements in this file, all these top level statements, and I'm especially looking at these, they are by default static allocated. Well, not for procedures, they use the code allocator, but for variables that are declared here, they are by default static, and you can see I've explicitly said static, which I believe is just not needed. And if we take a look closer, we can see the other places is also top level in this file. There's all these ones in the Linux file that we just looked at, and there's also a bunch in the GL file, which also are all at the top level, and they don't need to have static on them. So I'm just going to remove that, so none of them say static. And I think probably the best place to check that is by running OpenGL, and it still runs. So yeah, that's just a little tiny bit of cleanup. Another thing was I went and removed the cyclic import detection, which I think in hindsight was not a great idea. The one case that I can think of where it could be an issue, maybe I'll go back here, is like if instead of using something like this, I don't know, I think I allow basically anything to be here. So it could be like some other module dot some other var, you know? So now this module depends on that other module to set this value. But what if some other var in the other module, what if it was, you know, Linux dot this? Now that's just stupid, clearly, and won't work. So that's an example of where a cyclic dependency can go wrong, and I'd like to just avoid that. So I'm going to reinstate cyclic dependencies. I think it was this commit. Yeah, here's cyclic imports file. So that was in type checking. Cyclic imports dot Odin. Like so. Does it need all these? I guess it does. So when we're going to type check cyclic imports, I don't know where, I can't remember where we did it before. Is it statements? No, it doesn't look like it. Was it in main? I don't think so. Oh, maybe it was this file we removed, module. No. Loading? I don't see it in there either. Oh, Q reading from program. Okay. So it was like after we did the Q, so maybe I'll like take this. So basically it was right at the end of type checking. We type check everything and then we make sure, because the type checking process itself, if there are cyclic imports, it doesn't actually prevent that from working properly. So let's go to the end of type checking, type check Q, and then before generation, let's type check the cyclic imports, and I guess that will be at program. Is that okay? It's not okay, probably because we're using all return, which in this file we need to do this instead. Starting to feel like we should use just all return here, and then somewhere higher up we should do this OS exit 1. But anyway, that should reinstate cyclic imports. So I guess we could do a test, because a lot of things import this. And definitely core OS imports it. Well, actually, that might be the only one. Yeah, anyway. If I say I want to import OS from the same library, we should get an error. Yeah. Core OS Linux imported at path. There's the main one, core boomstick, core threading, which then imports core OS Linux, which then imports core OS, which then also imports core OS Linux. Yeah, so we have it sorted. So that's reinstated. So there's a couple of things fixed up. Now I wanted to have a look at this. Check if param names must match. Because at the moment, if I create an example where this rule gets violated, I think that'll be the easiest way to explain it. So if I have proc A, which is a procedure, and it takes a proc B, which is a procedure which takes a parameter X, and we'll call that a U8. And I'll just give that an empty body. And then we have a proc B, which is essentially this, right? Then we should be able to go proc A, we should be able to call proc A with proc B as the parameter, right? Because proc B has the same type as the proc B parameter. So these types match. So this should be okay. I mean, it's not going to do anything, but it shouldn't throw an error either. See? That's okay. Now, if I change this to Y, these types are not going to be the same anymore, and it should throw an error. Yeah, so now it's saying types proc Y U8 and type proc X U8 are not compatible. And I thought that would mess with the output, but I'm not so sure anymore. I think it's probably actually okay. And I think the best way to test it is to try and just remove that restriction and see whether it breaks it. Because I'm trying to think logically whether it would be an issue or not. And without really diving into the code, it's kind of hard. So I think the easiest way is just to like give it a go and see what happens. So if I go string.println, let's make this a string actually. Or maybe this one would be do strings.println x. No, this is going to call proc b. This is going to call proc b with like hello. Oh, I always do that. Always switching my keyboard layout. I went to the cafe this morning and used my built-in keyboard, which is UK. And here, proc b is going to print out x. So proc A is going to call proc B with hello, and proc B, I need to say do, proc B is going to print it out. So we should get hello at the start of our output. There we go, hello. Now if I change this to Y, we should get our error that we got before. Okay, now let's remove the restriction and see whether, like if if it's not going to work, then we should get some sort of like, I don't know, we'll probably get some sort of memory corruption because it might point at the wrong location in the assembly, or yeah, I'm not sure what would happen, but it would not happen. It would not work correctly, I think. So as long as this works correctly, I think that's good enough that I would be okay with it to just leave it like that. So we go AST util. Yeah, I was looking at this before. So this is the procedure, coerce type. So this is basically where we decide where the two types are equivalent. And it does a bunch of stuff looking at, like upgrading partial number types to concrete ones and things like that, and making sure that all that stuff works well. And assuming that the current node satisfies that it's the same type, then we recurse into the children. So for the type node that we're given to coerce type, we recursively go through all the nodes and make sure that they all satisfy the constraints, which is why it's enforcing that this X and Y are the same, because for any identifier it's going to enforce that. Now these are, in the AST, they are assignments, and in terms of types, the procedure type is the only type, I believe, that has an assignment inside of it. So here's the 3 complex types. See, it's actually a declaration, which is a subset of assignment. And these other ones, struct and enum, none of them have that. So we can be sure that we're not going to affect other types. So I think what we need to do is, when we're looping through the children, I think we need to have a special case. So we already make sure that A and B have the same type. So if we come across a node where that type is assignment statement, I guess, and we're looking at the first child. So we're looking at the first child of an assignment, which is the left-hand side of the assignment, and that which is this. Well, actually, all of this. So this will be left-hand side, and this is the data type of the left-hand side. I think in this case, basically, we want to skip down to the data type. We want to ignore this node and just skip down to this one. Yeah, I think that's it. So we need 2 equals. So I guess we need A child and B child. And then in the case where, then for the left-hand side, we want to go to, it's the data type of that node. And then we want to check that. So then we would put A child and B child into here. So for the other nodes, assignments have 3 children. First one's the left-hand side. Second one is the operator, like equals or plus equals or whatever. And the third one is the right-hand side. So for the operator on the right-hand side, we do as we did before. For the left-hand side, we skip down to the data type and check that. So we don't check for equality of these names. So if I run that, X has not been declared. That's unexpected. I wonder how that happened. Oh, if I look closely, 748, it's because the parameter is Y. We need to use Y here. That scared me for a second. I was like, why? So you can see it worked. Still prints hello. So I guess the name of the parameter doesn't matter. So that's kind of nice to take care of that. Maybe I'll just leave that here. We have lots of, like, a lot of the stuff in here, I guess we should actually convert into tests. So I'll leave this here so that we kind of know later to convert to tests. That's what this, I've got it at the top of bugs issues, but I'm probably going to do it last because it's a big thing. I guess this, and this is like more test stuff. Maybe I'll arrange this. So we don't need this anymore. Check if param names match. They don't need to. Calling procs from kernels. So this is a lot of glsl/kernel stuff. Okay, so we've only been going for a quarter of an hour. We've sorted one out already and done a couple of things from last time. So what's another thing that we can tackle? I'm kind of interested to do this one, actually. Some of these I think would need a little bit of research on my side before diving into them. But I think this one, and then we can, and these two here don't need research either, so I could try those after too. So let's try this. Intermediaries and out compiler parameters. So I touched on this when we, in a previous session, I think it was maybe a couple of sessions ago, we changed so that, like, if you're doing a project that's not in the same place as the compiler, which is going to be the case basically 100% of the time, that it actually works. And while I was at it, I kind of like realized that it'd be nice to have these parameters. But that's going to take a bit of change in this main, because at the moment we only have like one flag, which is like target, I think. And you can also use help. So I think I want to basically, like, often there's libraries for these sorts of things, and maybe there is a library in Odin, I don't know. But I'm just going to try and roll it myself. So that we get, so first I'm basically going to try and parse out all of the parameters, and then after that we'll dive into like the actual processing of the command. So this is true. So we might maybe, I kind of don't like the idea of flags coming first, but my thought is that if we just have a loop through all the arguments, and we'll skip the first one, because the first argument is the path to the executable, you know? Like, here's an example. This command right here is like Odin run source, blah, blah, blah. So this is the first thing that would be in the args list, and it's just where the executable you're running is. But we're not worried about that. We want all the things after. So I guess if it starts with, if it has a prefix of dash, then we're talking about an option. So we'll do some option logic here. And if we haven't specified a command yet, so maybe I'll say command string, and if command is still an empty string, can you do equals nil? I wonder if that works. Oh, no, it doesn't. In my language, that would work. So that's kind of cool. But anyway, if command has not been set yet, then we'll set the command to be the arg. And the next thing, because it's like command, yeah, and then a lot of the time there is the input. build has an input and run also has an input. So if input, then we do input. Otherwise, I guess we'll print an error. Print an error, which is like, and then I guess we'll just exit. So bang C, it's like unknown unknown argument, and then we put arg, or should we say invalid argument. We don't need to say command here because we have it defined up here. So how are we going to treat options? I think I'll make like a list of known options. Actually, I'm not sure. Let's have a think about this. So if it has a prefix dash, kind of what I'm thinking is we can have like a switch of, well, I guess not the whole arg. We can do split arg. Just, does it have a split? Yeah, strings.split arg around the equals. And so then if the thing before the equals, so I guess this is where like we don't need, I don't think we need that list anymore, because we'll say like if it's a help flag, then, well, so we will have I guess it's a map, string to string of options. So then we can say options help equals, let's just say true. There's also a target option. So then we can say target equals, but in this case, we would get split arg1. So this currently will allow you to do something like on the command line, you could do something like help equals some ridiculous value, and it will just interpret that as, it'll just ignore the the right hand side. Yeah, it'll just ignore that equals something, which I think is fine. Honestly, I don't think we really need to care about that. So let's help target. Are there any, I think those are the only two options so far. So this should, so I think if we find some other case, then again, it's like invalid argument. I don't know what that is. So that should provide all of our, that wasn't actually that hard, was it? So it assumes that command comes before input. Maybe I do like this setup right now means that the options could become before the command. So I think I'd actually prefer to do this. If we haven't set the command, then set the command. Then, so let's move these up like this. If we haven't set the input, set the input, but not all commands need an input. And if we want to get really tricky, we should also say that, you know, not all commands support all options, right? Like target is not supported by health check. Health check, you can't specify a target. Actually, run, you can't specify a target either because it has to be the target of the current machine to run it. So it's only build where you can specify a target. So we want to restrict that too. So yeah, and I want to know whether an input is valid. So we have this like valid command thing here, and if it's not a valid command, so, and we also used to just, whenever there was an issue, we would print the usage. I think I want to take that out. So like if there's an error, we just print the error. We don't print usage afterwards. So I'm just going to say if the command is not found in commands, well, I guess if the arg is not found in commands, then we say command is required to be one of, and we exit. Okay. And then input, well, I guess in some cases we just want to say invalid argument. So maybe we'll have like a map that says, I don't think we can define maps up here properly. So we can say, yeah, there's the commands and the targets. So or maybe we can just say commands with input. Maybe that will do. And then I can just basically take out health check because it doesn't. And then we can say oh, actually, it's not that there's it wouldn't be that there's an error. We would only do it if commands with input contains command. Then we would interpret the second parameter as the input. Yeah. Okay, nice. So now we're looking at the parameters. So now I think is where we have a map, which is like the command options. So that'll be a map of command to, can I just make it a slice? And then we can say command options build equals that. So for build, you can use, you can have help, and you can have target. For health check, do I even have a health check help? Did I go past it already? No, build, health check. No, I don't see, I didn't put any help for health check. So let's just make that an empty list. And then for run, we can use help but not target, like I said before. And then I guess, the other thing is that we can have help Like you can just run, you can just say bang c dash dash help, right? So that's, you haven't specified any command even. So maybe I can say slice dot contains command. So in this case, you can't go equals something. It's a bit inconsistent and funny, but whatever. So if we specify help right off the bat, then we would get this usage. And it would just be exit 0. And then we can specify a command. Okay. Now I wanted to limit, like we've specified what flags you can have for a command. So I wanted to limit which ones will work where. So I guess we can check afterwards. We can say for option and options. And then we can say if, what is it, like command options command does not contain the key that we put in, then we can say invalid argument, or invalid, we'll say invalid option in this case, because we've kind of lost some context, you know, it's just this string that we're looking at right now. So I'll just say invalid option target or help or T. No, it'll say target or help, because that's what we put into the map. Okay. I mean, I guess we could, because we do have the value, we could, well, then it would say help true. No, this is good enough. So this will make sure that we don't give the wrong option to the wrong command. And then I wanted to provide a default target also. And the default target is x86-64. So that would need to be, in the future, this would depend on what platform we're compiling on. Right now we only support that one. So so actually this loop, it should be after we've done everything. You know, we've processed all the arguments. And now we say, okay, did we specify any options we shouldn't have? And then if we should have specified a target, if command options command includes target, and target, do this a bit different. Target, we have to negate this. Target is not in options. Then we will add target to options. Oh, that was wrong actually. And we'll say it's the default target. So that's applying the default target. So we process all of the inputs. We make sure we haven't supplied any wrong options. We supply defaults to the options. This error is already like taken care of. This usage also is actually we've already shown that. And is valid command, we know now that it's a valid command. We've already got the input. See, this is where we had the default target here. So this processing is already done. Is valid target? Okay, that's a question. So I guess if we're dealing with something that needs a target, because up here we allow anything. Yeah, this is kind of just parsing things out, except for this. It does do validation of the command, but that's kind of necessary. Apart from that, it just parses everything out. And then here, I think we can have a separate if. So if the target's not an options, then we set it to the default. And then we say, so many slice.contains. Commands. Wait, do we already? This here we could also do, I guess, afterwards. I kind of like to have like all the validation here, I guess, after this loop. The usage we kind of need to I'm being a bit pedantic now. Let's just leave this. I think we just leave this. Because what I was thinking of was maybe in this case we can just set help to true and break out of the loop. And then print this later. But it's fine. It's fine. But now we need command, because arg should not exist. Yeah. Okay. So if targets does not contain options target, then we have an issue. Invalid target. We have targets required to be one of. Here it's using an error that's like specific to the, I guess this is also specific to the command. So we can put the command in the error. Invalid option. So target is required. So that should make sure that the target is valid. So we don't need this is valid target in here. Is help flag. So if we build required to be one of, input is required. Yeah, input is required. So I guess we can I guess if we get to this point, yeah, if command is an empty string, that's fine. Now I think it's like if input has not been set, but input needs to be required. So yeah, I guess it's the same condition. So if that still is the condition, like it's still waiting for an input and it needs one, then we'll say input is required. And again, we'll put the command in there. Okay, so that takes care of input is required. It takes care of all these basically. Then this is the usage. So I think really what we're trying to say here is like if options help is true, then print the usage. Very nice, and then we can continue as we want, but this is options target. Cool. I like that. I think this structure is actually kind of nice because then once we get down to this command switch, we know that everything is valid and we can just get to the business of doing what it tells us, what we've been told to do. That's nice. Health check doesn't take any parameters, so there's nothing for us to do. Input, we know is help flag. Input is required, we've taken care of that. Get rid of this. So we want to say like options help is true, then we print the usage. And that's it. So that should still work, hopefully. I mean, yeah, that still seems to work. If we run from the command line, bang c /bang c. Huh. Oh. I don't know why it didn't autocomplete, but now it's saying, okay, command needs to be one of these. Okay. So bang c, I want to run. Input is required. Okay. So I want to run examples playground. All right, that did it. And I want to build. I'm going to put this option in the wrong place. So I want to say target equals kernels. Invalid argument examples playground. Interesting. That's not quite the message that I wanted. It doesn't validate input at all, so it's like, okay, we found an input, whatever it was, that's fine. But then we got something else, and then it's like, okay, well, I don't know what that is. And I think, the case where someone puts this before this, it's not really very helpful. So maybe I'll provide an error in this case. We'll say invalid input. I think that's nice because we're expecting an input. So I did that because that builds it, and now we run invalid input. Okay, great. So if we take that out, and then I go after target equals kernels. Ooh, segmentation fault. I haven't done target kernels for a while. x86-64. So that's happy. Is JSON happy? Yes. But kernels is not. Okay, that's something we can have a look at. But the command line is happy. I mean, the command line is doing what I expect. Now, the thing is that if I do this, if I build that, so let's delete the output files. And here's all the playground files. So I do the build, and I get these 3 files. These 2 files, this file is executable. I want it, these 2 files. Generally, people that are using the language are not going to care about those files. We don't need them. So this is where I want to have another option called intermediaries. Intermediaries, I think that's how you spell it. So when you build and run, you can, both cases you can specify it. I don't see why not. So then in here, I'm not going to have a shorthand. You have to do it in full. Intermediaries, go like that. And so then when we get down to like a build, I'll put it on the end here. Intermediaries equals true. So it'll be a Boolean that we pass to build. And also to run, we'll pass that Boolean. So we'll say intermediaries. I was going to say we could have a default, but where else does run get called? Well, probably from tests, does it? No, it doesn't. Test uses build. Okay, good enough. But I don't think this needs to have a default now, actually, because we have the default that we can specify. So here we can go default target and intermediaries. Okay, I think that's all satisfied. So now in the build, we can decide what to do. I think it's actually going to be in compile, is it? Oh no, here it is. This is like where we do. So first we do the NASM call. That will create the assembly file. And then we do the LD command. And that will create the executable. So we already have the assembly file that's created by compilation. This creates the object file, this call. NASM creates the object file, and then this creates the executable. So we want to, this is compile. So here we want to like, it's kind of like we want to defer the deletion of the file. Is it os.remove, I guess? os.remove ASM path. But we only want to do it if not intermediaries. So I think if we put this whole, I guess this statement gets deferred. So if not intermediaries, remove the ASM path. And if not intermediaries, remove the object path. So if I run that, tests. So we need to say default target. And false. We don't want to keep the intermediaries. There we see. So now we have playground, but we don't have the other files. It deleted them. So if I do this one, goes like that, and if I say intermediaries, which is just helpful for me if I want to debug that assembly. There we go. Now we have the files. Perfect. The other thing I wanted to add a parameter for is the output, where the output goes. Because I think at the moment, somewhere in here, this is it here. When we do a run, see it has like /bin. What about build? Yeah, build also has bin. No, it doesn't have / in that case. I can't remember if we needed the /. I guess we'll find out. So I think now it would just be the input. That would be the default. So yeah, let's get to our options. Actually, another thing that we need to do is update our usage, because we have more options now. So when we do a build, we can say -- intermediaries. And then we can say like retain intermediate build files. Something like that. And same with this run did not have any before. So let's just copy all of this, all this option stuff. Well, I guess just this part. Yeah. Okay. So now I want to have an out parameter that you can specify for both of these. So we need to add it in here. So I'm going to have -o or -out, and you set a value for this one. And then I guess we have, this is where we have like our defaults, right? So, so we can say if the command wanted an out, and out is not in the options, then I'm just going to call it input. We'll call it input for now. We might want to change that later. Yeah, I think that's good. So I think that should validate. So yeah, the last part is that we then need to say, instead of this, we want to say input in options. If input is in options, no, if out is in options, then we use it. Otherwise oh no, we defaulted it. So we just always use it. Yeah, that's more simple. So, and also here. Yeah, so if I run that, it all works. Maybe I'll just delete all these files just to verify that it went to the same place. This is where it went. Because we don't have bin in the path anymore. Yeah, bin is not the default place. It just goes alongside, it just goes in the same folder. Well, it goes in the examples folder because the input is examples/playground. So if the output is also that, then it will go to examples/playground. which is fine, I think. So we can delete that. I guess we can delete the whole bin folder. But just as a test, we can say like -- out equals example/foo. And we see we got a foo file. And if I did run instead, just make sure that it actually runs that file. Yeah. Like if I delete both of these, it should create and run a foo file. Yeah. Okay. Yeah, I'm pretty happy with that. So now you can specify out, you can specify to keep the intermediaries. So we'll get rid of this. We're just under an hour. I wonder if there's something else that stands out as like a not too difficult thing that we could do without taking too long. Maybe we can have a look at the to-dos. There's quite a lot of them, but maybe some of them are kind of simple. What do we got here? Oh, the GSL stuff. Let's not get into that. Got a note that just says better. A bit hacky adds, yeah, that is hacky, I remember that. Need more testing of a certain thing. Namespace equals false, that could be nice, but I think that's going to take a bit of time. Why is this never used? I think it is actually used. Yeah, it is used. It's just that, like, if I try to find usages, CLion can't find them. It must be something to do with the LSP or whatever it is that's doing the stuff. I think it has trouble because there are, like if I go into here, allocators or something, see it imports just ... And I think when you do that, see it doesn't highlight. I wonder if I went /./generation. See, you kind of like need to name the folder and then it's happy. Yeah. So let's not do that. Where did we get up to? I think we looked at all of that. Something more targeted. This was a bit of an interesting one. That could be a contender. Is this needed? This is verifying for kernels that the first parameter is called index, but we just confirmed that names don't need to match. So I think we can cut that out and it should be fine. I hope. I guess we'll find out eventually if it's not. Oopsie daisy. I think I just put this in here just in case it might happen, but it never happens. So it's all good. What else we got here? Yeah, this essentially provides default types for integer literals. So I'm questioning whether that's what we want, but that's something to think about. Move to call. So the difficulty here, because I did try to move this, because I don't want to handle imports here. It makes sense for me that we do it at the call site, the problem is that we kind of need the whole statement because we need the left-hand side. Oh, interesting that we say left-hand side node for all of that. I mean, I think that can just be the node because I just want to see what do we actually need the left-hand side for. So now, whoops. Oh, I guess that would be statement, actually. So now we can see that the left-hand side is only used to get the reference, so that's essentially the name that we're referencing by. So I guess that part could be done, like we could have a call. I mean, it finds the path. It figures out the path, and then it says, okay, that's what we add. Lib name, module name, and that all comes from the right-hand side. And then that path is used here as well as there. Yeah, see, this is a little bit trickier. So I think we might just leave this one for now. I need to think about it a bit more. There's a bunch of stuff in the tests that needs attention. We want a proper map. Yeah, memory allocator doesn't work in these certain places. That's a known issue. Because the problem is that we need to solve this actually. The parser is responsible for knowing whether a return should have an expression after it or not. So if you put this here, what the parser sees is that this is a memory allocator, is the type. That's all it sees, just the identifier. It doesn't know what a memory allocator is. Or like a memory allocator is this type, it resolves to that type. But if I just put memory allocator here, according to the parser, there's no return type on this. It's not a procedure with a return type. So when we do return, it's not expecting this to be after it. And it processes that as if it's a whole new statement. So there's two separate statements. That's the problem. So really what we need to do is move that responsibility to type checking. So let's put that do return, it's like add expression to return in type checking. I don't know what the easiest is, because the problem is that the expression that appears after a return, because maybe we'll go back to, I'll just explain this a little bit and then I think we'll finish up. But the problem essentially here is that, like, if we look at our playground and see something like this, if this was like do return, depending on whether this procedure had a return type or not. So it doesn't have a return type. So this would be interpreted essentially as this, right? Because return shouldn't have anything after it. So this is a scope. So this is going to appear as a statement outside of that scope. So the one choice is that in parsing, we always put it here. And then afterwards, we move it down. But we don't know whether we should move it down, is the problem. Because all we know is it's a scope with this in it. So maybe it would end up becoming a scope with two statements, like this. So that's where the sort of like, it's a bit unknown. So maybe it's easier for the parser to just assume that return does not include something, so the parser will return this AST, and then when we find the return, essentially what we would need to do is, and this is difficult with our current structure, is search up the AST tree for the next statement after, which could be in a highest, like it'll search for the next statement in the current scope. If it can't find one, then it needs to go up to the scope above, look for the next statement there, and so on until it finds it, and then it needs to take it from there and put it here. And I guess it would need to stop at a boundary of like the procedure, right? It can't go past the procedure itself. Like if there was another statement here, you know, outside the procedure, it couldn't grab that one. So it's a tricky problem to solve because, yeah, parse time, we just don't know whether it should be there or not. So that's something to think about. Okay, but I think for now, we did good. We knocked off a couple of things off the list. We did add one, unfortunately. I mean, that was already an issue. It's just, I guess we just took it from the to-dos and put it here. But yeah, thanks for stopping by. Have a good one. Ciao for now.